Assalamu alaikum, Dr. Danlami. I'm Ibrahim, and I'll be explaining questions 1, 3, and 5. So I wrote this in the NASM program. I think I've already discussed this with you, that I wrote this in Linux. So this is the NASM program, and I will be running this now on my debugger. So this is a swap file, I called it, where we are swapping the two numbers. We're swapping the two numbers 1 and 9. First, we load the AX register with the value. We do an indirect access, so we get this value 1 using these square brackets, and access basically move the value 9 to the BX register, and this is to swap the two registers around, so this swaps their values. And over here it basically means that the value var1 is equal to the AX value, and var2 is equal to the BX value, so the var2 value is equal to the BX value. And then over here these are just like returning 0 to the operating system just to exit the program. I'll be debugging this so we can prove that it works. Step into, and if we want to see our variables, so since I started over here, I'll be doing x/gx, get the address of my variable 1, and we can see that my variable 1 is indeed 1, and variable 2 is indeed 9, right? And we can also do info registers and see how that changes. So right now our RAX register, which is AX, is loaded with the value 1, so it should be value 1 over here, which is indeed the case. So then we can move on to the second line and do the same thing. You can see how the values they obviously didn't change. They didn't change. So because now we also need to load the other register, the BX with 9, and you can see the RBX register is now 9. Move on to line 3, info registers. We have now swapped the registers, so now the RAX register is now 9 and RBX is now 1. We can go step even further, and now we should be able to see that the two values have indeed changed. Well, right now we've only done for AX, so only for var1, so we still need to do one more step, registers, and we can see that the registers have indeed switched their places, but now we just need to update the variables. So we'll just step one more time to the next line, and we can see the two different variables have now switched their values. And that's basically it for the first question. Now I will be moving on to the next question, which is question 3. This was the calculation question, where we had to explain. So the first thing we'll be doing in line 1, by line 1 I basically referred to this line. So move EAX var1. What we're basically doing over there is we're going to be moving the value of var1, which has a 5D, into the register EAX, right? In line 2, we're going to multiply EAX by var2, and the result will be stored in the EDX EAX area over here. Oh, that's what happens when we multiply it. And then in line 3, this part, what happens is we're going to add the value of var3, what are the value of var3 to the EAX register. So we're going to have 20 plus the EAX register. Then in line 4, finally, we're going to decrement the value of decrement EAX by 1 and store the result in var4. So the result will be stored in the variable 4. And we can do a demonstration quickly. So we can call the calculator. And we can step into it. And for registers, right, so we can see that RAX register is right now 5. We have executed this statement now. Step into again. We can see our registers update properly. So now we can see we have multiplied the EAX register by the variable 2, and the result is stored in the EAX, or in this case it uses RAX and stuff like that. So now we can go ahead and execute the third one. So I'm going to step into it again. And so in this case now we can see the registers updated again. What happened? We basically just added the value of var3 to the EAX register. So whatever we had on the EAX register, we added it. So in this case we're talking about, so EAX plus the var3 value, meaning we added 20, right? So 50 plus 20, we got 70. This is the decimal part, this is the hexadecimal part. And we can step in again, execute this last statement for decrementing, and we get 69 for that decrementing answer, which is then stored in the EAX register. And that's basically about it for this third question. Now we can then move on to question 5, which was this one. So over here on question 5, well, basically what's happening is we wanted to clear out the DX register. In the instructions, doctor, you give us the move DX and 0 and then move. In the NASM that doesn't really work because we have to specify the actual value for the opcode. So I just used the XOR, found the answer online. So they said just use XOR, it's fine. It worked perfectly fine. So we're going to be loading in the 1000 hexadecimal into the AX register. Then we load the 25 hexadecimal to the CX register, multiply the AX by the CX, and the result is stored in this DX register and AX. And again, obviously we're just going to be exiting the program. We can take an example to that, GDB debugger, and I called the file question 5. Start, run, yes. Right, and so now we're basically going to step into it. Info registers. And so right now everything is going to be 0 because we execute the statement, so it's going to be cleared up. Step into it again, and on the second execution statement we're going to load our AX register, and that's updated. 1000 hexadecimals loaded up there, and step into it again. We can see that the RCX register should be loaded up with the 25 hexadecimal. Yep, and these are the decimal values. And we can step into it again and execute this multiplication statement. And we can see we said that the result is stored in the DX register, so we can see that in RDX stored the 2 value. And that's basically about it, because last we had to just multiply the AX by the CX. AX had this 407 4096, multiply that by that, so we get our answer. And that's about it. Thank you. Hello doctor. So today, so since my teammate, he decided to not work with me last minute, I had to complete question 2, 4 and 6, so I'll just be adding this to the previous video I created. I'll keep this quick. So this is question 2, and what basically happens in the first line of the starting point is we move the values stored in the memory variable xval, so whatever's in the x value we'll put in the EAX register, and then afterwards we're just going to negate the EAX register. We're just going to perform 2's complement. Then on this third line, we're going to move the value of yval, which is 30, to the EBX register into the so move 30 to the EBX register. Same thing with zval. We're going to move 40 to this is subtraction, so we're going to subtract zval, which is 40, from the EBX register. At this point we're going to add EAX with the EBX. That's basically it. So we're gonna add the results of whatever we had, what computation we did over here, so the subtraction, and we're just going to add that with the x value, because the x value is in the EAX register, so we're just going to work that with the zval. So then later on we're just going to increment the EAX register by 1 to just do the arithmetic operation which was in the question. And lastly, in our last line, we're just going to move the final value that we have computed in our EAX register from EAX to the R value. And this is just to exit the program. I'm not sure if I'm supposed to debug this, but I can quickly show a quick demo that this does indeed work. So yeah, we have about 6 lines of code, so we can step in 6 times. 5, 6, and then we can do info registers, and we can see the final output is the one from my document I've submitted, which is the correct answer. So the FFF6, and the main thing we want to look at is the EAX register, which so this value was passed into the R value, this one, which has the decimal value of this. Okay, and now we can move on to the question 3, I think. 4. Question 4. Right, question 4. And so now over here in question 4, what's happening basically is that it's almost the same as the other one, but on the first line, or the first execution, is that we're moving the value of variable 1 into EAX register, and then same thing with this one, we're putting the immediate value 5 into the BX register, multiply the BX, or what basically means is the result stored in and on this multiply line, we basically just multiply AX by BX, and the result will be stored in DX AX. On this line, where we're basically saying we're loading the value of whatever variable 2 is, so var2, which has a 10 decimal, into the BX register. Right, we're putting that in the BX register. Subtraction, so subtracts 3 from the BX register. Here we're just dividing the BX register, so divides the DX AX by the BX register. So then we're moving the AX register in, oh sorry, we're storing the quotient because we're doing a quotient thing over here, and we're putting it into the value of variable 2. Could do a quick demo to show that it works. So it's question 4. I have about 6 lines of code, so step into 6 and 4 registers, and we can see the result is as we have it. The value AX, meaning this one, so 28 was stored, or this hexadecimal value was stored, which is indeed correct according to the question. And lastly, we can now move on to question 6. Question 6. Basically, what on question 6 is happening is we are first of all, we're going to again, like question 5, I believe, we're clearing it. We're moving this value, the immediate value, to the AX register. Then we move the immediate value 10 hexadecimal to the BL register, and then we do the division of the AX column, and then divided by BL, and then move the AL register into the quotient. So basically we store one of the register values into our variable, because we have a quotient and a remainder because of our division, and we're going to have a remainder variable. So AH is our remainder, AL is our quotient, and this indeed does work. GDB question 6. Break start and run this. Have about 5 lines of code, so step 2, 5, and for register. And so here we can see the actual result. The AH has a value of 0, 3, and the AL has a value of like 8, 0, which is in hexadecimal, that's the remainder. So because it works in like little endian order, the most significant is on the left, the least significant is on the right. And that's it. Thank you, doctor.